Which one of these ice cubes will last longer? The answer looks almost too simple. But here's the surprising part. You're not keeping the ice cold. You're stopping heat from getting to it. Ice doesn't melt because it gets tired of being ice. It melts because it absorbs energy, specifically heat. Heat naturally flows from warmer objects to colder ones. The room is warmer than the ice. The table is warmer than the ice. Even your hand is much warmer than the ice. So heat is constantly moving into it. Every second, the ice is being paid in energy. And once it gets enough, it changes state. Heat reaches ice in three main ways: heat moving through direct contact, warm air moving around it, heat energy arriving from warm objects and sunlight. So if you want ice to last longer, you have to reduce one or more of those pathways. And that's where something as boring as a towel comes in. A towel contains lots of tiny pockets of trapped air. Air is a poor conductor of heat compared with metal. Those air pockets make it harder for heat to travel through the material. The towel doesn't make the ice colder. It simply slows the heat transfer. That's the same basic reason jackets keep you warm. They don't create heat. They slow heat from escaping. Now compare that with metal. Metal is an excellent conductor of heat. So when you put ice on a metal tray at room temperature, heat flows into the ice much faster. Wood and many insulating materials transfer heat much more slowly. That's why the same ice cube can survive noticeably longer on one surface than another. But here's something many people overlook: moving air. Warm air constantly replaces the cooler air next to the ice. That increases heat transfer. So if you're trying to keep ice, don't put it in front of a fan, unless your goal is iced water. So what's the best way to keep ice from melting? Foam and other insulating materials slow heat transfer. Opening it lets warm air in. Radiation from the sun adds heat. More cold mass and less warm air can help the contents stay cold longer. So the secret isn't finding something magical that stops melting. It's reducing heat transfer. The less energy reaches the ice each second, the longer it stays solid. So if someone asks you how to keep ice from melting, the answer isn't make it colder. It's keep the heat away. Because ice doesn't need cold to stay frozen. It needs less heat. That's why an insulated cooler can outperform